Thank you very much, fellow Kenyans. I'm Babu Owino, Member of Parliament, Embakasi East Constituency. I want to take this opportunity to revise with the candidates, the Form 4 candidates who are going to sit for the exams starting in November. I want to take this opportunity to wish you all the best, and just know that education is an equalizer. Just know that education is the passport to the future, and the future belongs to those who prepare for it today. Just know that education has bitter roots but has very sweet fruits. Just know, candidates, that if you open the doors of a classroom or the gates of a school, you will definitely close the gates of a prison. Just know that it is through education that will make you leave your various villages, the various slums, that will make you at least remove your parent from the shackles of poverty. As to what education did to me, way from Nyalenda slums, and now here, it can do that to you. To the parents, continue doing whatever you are doing. Kwa mama mboga, uza hiyo mboga yako. Kwa bodaboda, endesha hiyo bodaboda yako. Enda kwa mjengo, oshia tu watu manguo. Lakini siku moja, ninajua unafanya hayo yote ili upate pesa ya kulipia mtoto wako karo ya shule. Siku moja Mwenyezi Mungu atakubariki through huyo mtoto wako, kutoka kwa huyo mtoto wako. Usichoke naye, tujaribu kuwa bring up tu vizuri sana kwa candidates wetu, never give up. Positive thinking brings positive results. Negative thinking brings negative results. I want to start with mathematics revision to our candidates. This is just to motivate you to know that it is possible. If I did it all the way from Nyalenda slums, you can do it. You have an advantage even over me to do it, to pass your exams, to move from secondary school all the way to university and graduate. And I know, when I look at myself, I see you. And when I look at you, I see myself. You can be a doctor, you can be an engineer, you can be a teacher, you can be a businessman and businesswomen, you can be a leader like myself, you can be an actuary, you can be an advocate, you can be anything you want to be in this nation. It is just the thinking that makes it so. Remember, nothing is either difficult or easy, but thinking makes it so. I wish you all the best in your examinations, and as we start today, just prepare. In mathematics, as usual, practice makes perfect. Always remember the 6 P's. First P, proper prior preparation prevents poor performance. We want to start with our revision. We have a total of 12 topics, questions in 12 topics to handle. These topics are commonly set. If you look at the past papers, in the previous years, over the past 15 years, past 15 to 20 years, these topics have never missed in examinations. And I can assure you that in this year's KCSE, these topics will never miss. Questions will come in these topics. And that is topic number 1, LCM. Topic number 2, algebraic expressions. Topic number 3, variations. Topic number 4, vectors. Topic number 5, equations. 6, decimals. 7, indices. 8, matrices. 9, fractions. 10, differentiation. 11, binomial expansion. And 12, further logarithms. Enjoy your lesson. We're going to do a total of 20 questions, and I know you will enjoy your lesson. Karibu, on to our first question. Question 1 is the GCD of 144 x cubed y squared and 81 x y raised to power 4. So this is a simple class. Candidates, first of all, before you start your exams, make sure you pray, because the Bible says that you seek ye unto the kingdom of God first, and every other thing shall be added unto you. So first of all, we have 144 x cubed y squared and 81 x y raised to power 4. So we are going to find the GCD of 144 and 81. So first, get the GCD of 81 and 144. So here we are going to use prime factors. We will get a number that can go into both 81 and 144 without a remainder. So the least number, let's try taking 2. If we take 2, 2 can go into 81, yes, but there will be a remainder. But 2 can go into 144 without a remainder. But because there is a remainder here, we go to the next number, which is 3. 3 can go to both 81 and 144 without a remainder. So we have 3. So 3 can go into 81, 3 can go into 8 2 times, which is 6, remainder 2, into 21 7 times. Then 3 can go into 14 4 times, which is 12, remainder 2, into 24 8 times. Then again we try 2. 2 goes into 27, yes, 13 times, remainder 1, but goes into 48 24 times, but there is a remainder. So we go again to 3. 3 goes into 27 9 times. 3 goes into 48 once, into 18 6 times. So it goes there 16 times. Can 2 go into 9 without a remainder? Yes, it can go into 9, but there will be a remainder. Can 3 go into 9? Yes, it can go. Can it go into 16 without a remainder? There will be a remainder. It will go there 5 times, remainder 1. Can 4 go here? There will be a remainder. So we leave it at that. So the GCD, because of these two numbers, already there is no number that can go into both without a remainder. So we leave it at that. So the greatest common divisor of 81 and 14 is 3 times 3, which is 9. That's done there. Then remember, we have x cubed y squared and xy raised to power 4. So we have x y raised to power 4 and we have x cubed y squared. So we want to get the letters. These are letters. We have x and y and we have x and y. So we want to look for a letter that can go into both xy raised to power 4 and x cubed y squared without a remainder. So because xy is common to both, so our first letters are x and y. X goes into x once without a remainder. Y goes into y raised to power 4. It goes there y raised to power 3 times. Then x goes into x cubed, x squared times. Then x goes into y squared, y times. Here, which letter can go into both without a remainder? We see that y is common to both, but x is not common to both. So we take y. So y goes into y cubed or y raised to power 3, y squared, y raised to power 2 times. Then y goes into y once, and then we have x squared. Therefore, any letter that can go into these two again without a remainder, there is no other letter. So the GCD of y of x y raised to power 4 and x cubed y squared is x y, this times, that dot means times y. This comes to x, y times y is y squared. By the laws of indices, if you have common letters or common numbers, you just write that number, then you add the powers. So this means that y raised to power 1 times y raised to power 1, which is y, then 1 plus 1 is 2, which is y squared, or y times y is y squared. So the GCD of 144x cubed y squared and 81xy raised to power 4 is 9 times x y squared. Now this comes to 9, I need another felt pen, xy squared. So that is the GCD. So the next question, there's a part B of that question, which tells you, question 1B, which tells you, hence factorize completely this expression, the expression of 144x cubed y squared minus 81 xy raised to power 4. So you are told to factorize this completely. But from A, we found that the GCD, which is a common factor, greatest common is 9xy squared. So just come here and write 9xy squared. When you factor it out, you say 9 goes into 144 how many times? 144 divided by 9. 9 here once, 9 here once, remainder 5. Into 54, 6 times. So it goes 16 times. Then x goes into x cubed, x squared times. Then y squared goes into y squared once. So it remains like that, minus 9 goes into 81, 9 times. X goes into x once. Then y squared goes into y raised to power 4, y squared. So from here, you can see something not funny but very familiar in this bracket. You see 16 xy squared. 16 can also be written as 4x, but they have a common squared, minus 3y squared. So I want to explain this again. 16x squared can also be written as 4x everything squared. So 4 squared is 16, x squared is x squared. 9y squared can also be written as 3y everything squared. So when you look at this, we remember something called a difference of two squares. So by a difference of two squares, here we have 9xy squared, just drop it down, 9xy squared, into a difference of two squares tells you that when you are given a challenge like this, then it means that it is 4x minus 3y into 4x plus 3y. When you expand this, you get this. But this is further simplification. It's called a difference of two squares. So from here, use difference of two squares. From first, by now, you know this. Or rather, you should know that. Now, that is question 1B. Then we go to question 1C. So we've already factorized. That is to factorize, means simplify further. Then question 1C. The LCM of three numbers. Class, this one I think I can bet that it is going to come. Such a question, even that question 1 is going to come. Question 1A. The LCM of three numbers is equal to 7,920 and their GCD equals to 12. Two numbers are, one is 48, the other one is 264. Using factor notation, find the third number. Find the third number. We want the third number. Find the third number if one of its factors is 9. If you're given such a question, first of all, just smile because it's so easy. These are easy marks. So anytime you are given such a challenge, that the GCD of a number is given, LCM is given, you are given two of the numbers, they want a third number. Just say the third number equals to the GCD times LCM over LCM of the two numbers. GCD times LCM over the LCM of the two numbers. So we have the two numbers, get their LCM. So LCM of 48 and 264. The least common multiple, start with 2, 2 here 24, 2 here 132, then 2, 2 here 12, 2 here 66, then 2, 2 here 6, 2 here 33, then 2, 2 here 3, then you bring down 33, then 3, 3 here 1, 3 here 11, then 11, 1, 1. Remember, I told you when you're finding LCM, they want the least common multiple. So you ensure that whatever you get here is 1 and 1. So this is the LCM. Therefore, LCM of 48 and 264 equals to 2 raised to power 1, 2, 3, 4 times 3 times 11. Okay? 2 times 2 times 2 times 2. This is 4 times 4. This is 16 times 3 times 11. So once you get this, come back here. Say the GCD, our GCD is 12 times our LCM is 7,920 divide by our LCM of the two numbers, which is 16 times 3 times 11. So let's divide 11. Let's start with 11. 11 goes here once. 11 goes into 79 7 times, which is 77, remainder 2 into 22 2 times, then 0. Then we go to 3. 3 goes here once. 3 goes here twice, which is 6 into 12, remainder 1 into 12, 4 times, then 0. Then let's go to 4. 4 here 4 times. 4 here 60. Then let's go to 4 again. 4 here once. 4 here 15. So we remain with 12 times 15. This is 180. Very easy. Now, class, you can be told there's a sum that you can also be given the GCD and the LCM, and then you are only given one number. In case you are given one number, then the formula remains the same, but it is GCD times LCM over one of the number, over the number given, over the number given, or over the LCM of the number given, not two numbers now. If you are given two numbers, is LCM of these two numbers, but if you are given only one number, it is the LCM of that number or that number. So I think that's very precise and accurate. Question number 2. So as Form 4s, I'll try to move a little with a little speed so that at least we save some time. So question number 2, simplify. Remember, you are told to simplify completely. 2 into x squared minus 36 divide by 2x squared minus 7x minus 30 divide by x minus 4 over 2x plus 5. So in this, look at this. I want you to solve them separately. So solve whatever you are given in the first column here. So we have x squared minus 36. There's something unique about this. Remember, I told you something to do with the difference of two squares. So x squared minus 36 is the same as x squared minus 6 squared. So solve whatever is at the numerator here. We have 2 into x squared minus 6 squared. This can also be written as 2 into x squared minus 6 squared is the same as x minus 6 into x plus 6. A difference of two squares. So we've solved this part up. The numerator come to the denominator. Denominator here is 2x squared minus 7x minus 30. This is what we call quadratic equation. So in the quadratic equation, look at two numbers. When you multiply them, gives you 2 times 30, which is 60. When you multiply them, gives you 60. When you get their difference, or when you subtract them, gives you negative 7. So what are these two numbers? Gives you negative 7x. What are these two numbers? So you multiply 2 times 30, you get 60. So the easiest way to do it, first of all, get values, get the factors of 60. So 60, get two numbers, factors of 60 are 60, 2 here 30, 2 here 15, 3 here 5, and 5 here ones. So factors of 60 are 2 times 2 times 3 times 5. So factors of 60 can be 2 times 30 or 4 times 15 or 12 times 5 or 60 times 1. So all these are factors of 60. So if you get all these factors of 60, which are two numbers, if you multiply them gives you 60, all these can give you, but if you add them gives you 7. If you subtract them, gives you minus 7. So here if you subtract, you get something different, around 28. This one gives you 11, this one gives you 7. So the two factors that we are looking for are 12 and 5. Therefore you come here, this is just a rough draft. Therefore you come here, 2x squared minus 7x minus 30. So the two numbers are 12 and 5. So you come here, you get 2x squared plus 5x minus 12x minus 30. Solve this quadratically in short. So what do we get? The common factor here in these two is x. So x into 2x squared is 2x plus x into 5x is 5 plus, no, minus, sorry, here is minus, this is minus. What is common between 12 and 30? That is 6. So 6 goes into 12x, 2x times. Then minus, okay, you take it with its sign. So minus 6 goes into minus 12x, 2x times. Then minus 6 goes into minus 30. Minus and minus becomes plus 5 times. So when you look at this, you find that in this bracket and this bracket, they are common. So you collect x minus 6. You take this x and minus 6. Then you take one of the common factors in the bracket here, which is that. So when you factorize this, you get this. Therefore, come back here, write it in simplified form. In simplified form, we had our first one as 2, the numerator, into x minus 6 into x plus 6. Then the denominator is x minus 6 into 2x plus 5. This is this simplified. Then come here. If you divide this by this, if you want to change the division sign by multiplication, you multiply by the reciprocal of this. Now this comes up. So x minus 4 over 2x plus 5 becomes times 2x plus 5 over x minus 4. So from here, you can simplify, you can cancel. You can see x minus 6 and x minus 6. So this cancels that. Then we have 2x plus 5 and 2x plus 5. So what do we remain with? We remain with 2 into x plus 6 over x minus 4. That's our answer. Question number 3. Question number 3. A quantity P, this is variation, a quantity P varies partly as Q. So quantity P varies partly as q and means plus partly as the square root of q. Partly as the square root of q. So quantity p varies partly as q and partly as the square root of q. First of all, before you proceed, you open this up. So when you open it, p, when you get rid of this sign, you equate it, you replace it with equal sign. Then you will have to introduce variables, but two variables, because they partly vary with q and partly varies with the square root of q. So if you say p equals to, when you replace this sign with an equal sign, then introduce a variable h, q, plus, if you introduce a variable for q here, you introduce a variable for the square root of q. So let's say the variable is t, the square root of q. Once you do that, you finish this sum. So you just do the replacement. So what does the question say? A quantity p varies partly as q and partly as the square root of q, given that p is equal to 30 when q is equal to 9. So p is equal to 30 when q is 9. So 9h, just replace, plus t into the square root of 9 when q is 9. And p is 14 when q is 16. So 16h plus t, the square root of 16. Then you are told find p when q equals to 36. So find p when q equals to 36. So from here we have two variables, h and t. So we get the values of h and t, then we replace in this equation with q as 36. We'll get our value for p. So what do we do here? Very fast. This we can solve this. So this is 30 equals to 9h plus the square root of 9 is 3 times t is 3t. Then this is 14 equals to 16h plus the square root of 16 is 4 times t is 4t. So when you look at this equation, these are called simultaneous equations. So the simultaneous equation, we can solve this by either elimination or substitution method, whichever one you prefer. So we can do by substitution, because you can see that in the first equation we can divide everything by 3 here. So if you divide by 3, you get 10 equals to 3h plus t. Then make t the subject of the formula. Therefore t equals to 10 minus 3h. By substitution, come and replace the value of t here. So 14 equals to 16h plus 4, but our t is 10 minus 3h. We want to get the value of h. So 14 equals to 16h plus 4 times 10 is 40 minus 4 times 3h is 12h. So you must be careful as you multiply so that you don't make any mistake. Then collect the like terms. So 14, when 40 crosses this side, becomes minus 40 equals to 16h minus 12h. So 14 minus 40 is minus 26 equals to 6h minus 12h is 4h. Then divide both sides by 4 by 4. So h equals to 2 here 2, 2 here 13, becomes minus 13 over 2. So once we get the value of h, now we calculate the value of t. So the value of t, just come and replace it here, substitute. Where there is h, you write this to get the value of t. Therefore t will be 10 minus 3 into h. h is minus 13 over 2. So t equals to 10 minus 3 times minus 13 is plus 39 over 2. Get the LCM is 2. 1 into 2, 2 times 10, 20, plus 2 into 2 once times plus 39 is 39. So t equals to 20 plus 39 over 2, which is 59 over 2. So we have our value of t. We have our value of t and h. Therefore, come in our original equation. What does now the question want? The question tells you to find P when Q is 36. So, come back here, find P equals to HQ plus T the square root of Q. Remember, these are constants. H and T are constants. Q are variables and P. These are variables. Therefore, P equals to H. H is what? We got our H as minus 13 over 2 times Q. Which Q are we given? 36. Plus T. Our T is 59 over 2 times the square root of Q, 36, because we want to find the value of P. So P equals to 2 here once, 2 here 18 times. So 18 times 13, calculator very fast, 18 times 13 gives you 24, 54, 8, 1, 4, 3, 234. Gives you minus 234 plus the square root of 36 is 6. So that is 59 over 2 times 6. Here once, here 3. So 59 times 3, you get 59 times 3, 27 to 15, 177. So P equals to minus 234 plus 177. So P will be 234 minus 234 plus 177. Take care of the signs, class. So this comes to 234 minus 177, 57. So it becomes minus 57. So class, our value of P is minus 57. So you must be very careful. Such a question will never miss. Question number 4. The sum of two numbers, this is just jogging around with your mind. The sum of two numbers exceeds, let the two numbers, okay, let me read the question first. The sum of two numbers exceeds their product by 1. Their difference is equal to their product less 5. Find the two numbers. So sum of two numbers, let two numbers be equal to A and B. So the sum means plus, addition. Their sum is A plus B, is the sum of two numbers exceeds their product. Product is A times B by 1. So when you are told the sum of two numbers exceeds their product by 1, means that if you add them, for them to be equal, then you have to add 1 to the product. So A plus B equals to AB plus 1. Their difference, A minus B, is equal to their product, AB less 5. Find the two numbers. So very fast, let's not waste time on this. These ones are simultaneous equations. So by substitution, we can substitute the value of AB, then we replace it. This is equation 1, equation 2. So let's make AB the subject of the formula. So AB will be equal to A plus B, then minus 1. So where there is AB in the second equation, you replace it with this. So this is A minus B equals to A plus B, sorry, AB, but AB is A plus B minus 1 minus 5. You bring down this 5. So A minus B equals to A plus B minus 1 minus 5 is minus 6. Collect the like terms. A crosses the other side becomes minus A. Then minus B, B crosses this side becomes minus B equals to minus 6. Therefore, A minus A is 0, but minus B is minus 2B equals to minus 6. Divide by minus 2 both sides. So B equals to 3. So when B is 3, what is A? So anywhere there is B, you write 3 to get the value of A. So you come here. So A minus B, but B is 3, equals to A times B. B is 3 minus 5. So A minus 3 equals to A times 3 is 3A minus 5. You rearrange, then collect like terms again. A, take 3A this side, becomes minus 3A equals to minus 5. Take 3 the other side, becomes plus 3. So minus 2A equals to minus 2. 3 minus 5 is minus 2. Divide by minus 2 by minus 2. A equals to minus 2 divided by minus 2 is 1. Therefore, the question wants, find the two numbers. So the two numbers, A is 1 and B is 3. As simple as that. So let's see. Let's try to prove this. A plus B. A is 1. A is 1 plus B is 3. Is it equal to AB? A times B. A is 1 times B is 3 plus 1. So this is 4. Is it equal to 1 times 3 is 3 plus 1 is equal to 4. Is equal to 4. So does it also make sense in the equation number 2? A is 3. A is 1 minus B is 3. Is it equal to AB 1 times 3 minus 5? So 1 minus 3 is minus 2. Then 1 times 3 is 3 minus 5. So minus 2, is it equal to minus 2? Hii umepata kabisa. So our numbers are 1 and 3. Question 5. Please, as you watch, kindly share that video so that at least those who can't get it, who can't be reached, can so that we can access those who can't reach us. So the next one is question 5. Evaluate minus 12 divided by minus 3 times 4 minus 15 divided by minus 5 times 6 divided by 2 plus minus 5. So such a question just requires you to be very attentive. So this just apply BODMAS. BODMAS is even in primary school. So this question you should not get it wrong at any time. So you solve the numerator, then you come and solve the denominator. So the numerator, applying BODMAS, we have brackets. So wherever there is a bracket, you open it up. So minus 12, very fast, divide by, you open it up, divide by minus 3 times 4, minus times minus is plus 15. Then come to the denominator, minus 5 times 6, divide by 2, then plus times minus is minus 5. Come here, after bracket you go to of, is not there, go to division. Now come to the numerator and divide. Minus 12 divided by minus 3. Minus divided by a minus is a positive. 12 divided by 3 is 4. So that is 4. Times 4, rewrite it, plus 15. Divide by minus 5 times, then 6 divided by 2 is 3 minus 5. Then after division, go to multiplication, come down here, multiply, 4 times 4 is 16, then plus 15, divide by minus 5 times 3 becomes minus 15, then minus 5. Then addition, add them, the numerator 15 plus 16 is 31, over, divide by subtraction, the denominator. Minus 5, minus 15 minus 5 is minus 20. So this is our answer. Or if you simplify it further, it becomes minus 1 and 11 over 20. So this you have to solve without a calculator, because if you use a calculator you will only get your answer but you will not get the steps. So they'll only give you 1 mark for the answer. Question number 6. Question number 6. Given that the vectors A equals to 2i plus 4j and B equals to 2i minus 3j. Find 2a minus 3b. Find the modulus. When you see this sign, it means the modulus. The question can tell you find the modulus, or find the size, or find the magnitude, or find the length. Question can be set in any of these 4 ways. Find the modulus. This sign means the modulus, or the size, or the magnitude, or the length. So just replace the modulus of. This one is given in the unit vector form, the unit vector ij, unit vector ij. Write it in the column vector. So this is written in the unit vector form. So write in the column vector form ij. So A can also be written as 2, 4, 2, 4, and B can be written as 2 minus 1. Then come and replace here. Modulus of 2 into A. What is our A? 2, 4. Then minus B, minus 3B. 3 into what is our B? 2 minus 1. You replace that. So 2 times 2 is 4. 2 times 4 is 8. Minus 3 times 2 is 6. Then 3 times minus 1 is minus 3. Then open it up. 4 minus 6 is minus 2. Then 8 minus 3 is the same as 8 plus 3, which is 11. So when you are told to find this, you've simplified from here to here. This means the modulus or the size. It means that minus 2 squared plus 11 squared into the square root to get the size. So minus 2 squared is 4 plus 11 squared is 121 into the square root, which is the square root of 125. So use your calculator to get the square root of 125. So the square root of 125 can also be written as the square root of 25 times the square root of 5. Square root of 25 is 5 root 5. This is our answer. Further simplified is 5 times the square root of 5 is 2.36 something. So when you get this, you get 11.8. 11.18. So the square root of 5 is 2.2. Square root of 5 is 2.236 times 5 is 11.18 units, because they want the size, the length, the modulus, units. That is our answer. So next one is question number 7. This is on vectors. Question number 7, very common. A point P divides line AB in the ratio of 7 to minus 5, where A and B are the points A 254 and B minus 472. Find the coordinates of P. So a point P divides line AB in the ratio of 5 to minus 2. This is external division of a line. So we have two types of division of a line. There's an external division of a line. That's why it divides line AB into the ratio of 5 minus 5. That's an external division of a line. And there's an internal division of a line where there is no negative. So just draw the line. So you are told a point P divides line AB in the ratio 7 to negative 5. So divide this in the ratio of 7, 1, 2, 1, 2, 3, 4, 5, 6, 7. So this is A. So a point P divides AB in the ratio 7 to negative 5. Remember, you are going like this 7, then you are coming negative 5. So which means from here you count 5, 1, 2, 3, 4, 5. So this is our B and this is our P. So P divides AB externally. Again, P divides AB, line AB externally in the ratio of 7 to negative 5. So are we clear up to there? So if A you are given 2, 5, 4. The coordinates of A are 2, 5, 4. While the coordinates of B are minus 4, 7, 2. Find the coordinates of P. So find the coordinates of P. There are two ways of doing this. The shortest way is what we call the ratio theorem. The ratio theorem. So by ratio theorem, AP point P divides line AB in the ratio of 5 to negative 7. Therefore, AP ratio PB, AP ratio PB is 7 to negative 5. So this will take this and this will take this. Therefore, the coordinates of point P equals to 7 over the total ratio. Total ratio is 7 plus minus 5 is equal to 2. So becomes 7 over 2 of B plus minus 5 over the total ratio 2 of A by ratio theorem. Therefore, P equals to 7 over 2 of B. What is B? The coordinates of B, they are minus 4, 7, 2, plus times minus is minus 5 over 2 of A. A is 2, 5, 4. So what's common in these two is a half. 7 over 2 and 5 over 2. What is common there is a half. Therefore, P is equal to a half. Then we solve what is in the bracket. 7 times minus 4 is minus 28. 7 times 7 is 49. 7 times 2 is 14. Minus 5 times 2 is 10. 5 times 5 is 25. And 5 times 4 is 20. Remember, class, we've factored out a half. So we've taken care of a half because it is common in both sides. So we will use it later just to ease our work. So from here, we have P equals to a half into minus 28 minus 10 is minus 38. 49 minus 25 is 24. 14 minus 20 is minus 6. Then multiply by a half. So P equals to a half times minus 38 is minus 19. Then a half of 24 is 12. Then a half of minus 6 is minus 3. Remember, this is in column vector form. So you are asked the coordinates of P. So how do you write your answer? Because if you leave it like this, is still wrong. This is not in the coordinate form. So the coordinate form, you write the coordinate of P is P into minus 19, 12, minus 19, comma, 12, comma, then minus 3. So this is by use of ratio theorem. Let's use another formula. We see there are different ways of killing a cat. So let's use another formula. So just write point AB. We see if our answer comes to the same answer. So our point A is that, first of all, divide it just in that ratio. We said this is our P. Then now 1, 2, 3, 4, 5, 6, 7. So this is our B. This is our P. So our A, coordinates of A are 2, 5. Coordinates of A are 2, 5, 4. And coordinates of B are minus 4, 7, and 2. So this line, the point P divides AB in the ratio of 7 to minus 5. So we want the coordinates of P. So if you want the coordinates of P, let's drop it from the point O, from the origin. Just draw that. So mark there point O. So we want to move from O to P. So how do we move from O to P? If you want to move from O to P, you can move from O to A, then A to P. This is OB. So O to P, class, OP equals to OA plus AP. But AP, pay attention, AP equals to 7 over the total ratio, 7 over the total ratio, which is 2, of AB. But AB means B minus A of 7 over 2. Then you drop this plus, drop this OA, then OP. Very interesting. So OP equals to OA. What is OA? OA is 254 plus 7 over 2 of B. Our B is minus 4, 7, 2 minus A. Our A is 2, 5, 4. From here, 254 plus 7 over 2, then solve what is inside here. Minus 2, minus 4 minus 2 is minus 6. 7 minus 5 is 2. 2 minus 4 is minus 2. Then further solve it. Open the brackets. Becomes 254 plus 2 into minus 6. Okay. Multiply 7 over 2 times minus 6. 2 goes here once, 2 goes here minus 3. Minus 3 times 7 is minus 21. Then 7 over 2 times 2 is 7. Then 7 over 2 times minus 2 is minus 7. Then let us open up this. We have 254 plus minus 21, 7 minus 7. So OP equals to 2 minus plus minus 21 is the same as 2 minus 21, which is minus 19. 5 plus 7 is 12. 4 plus minus 7 is 4 minus 7, which is minus 3. So I think we are coming to the same answer. So OP is equal to 19, 12, minus 19, 12, minus 3. But the coordinates of P is minus 19, 12 minus 3. You write it in this form. I think this is the same as this. Is it? Is the same as this. So we are right. So you can use the ratio theorem or you can use this other route. They are both correct. Now we are going faster. Question number 8. Find the equation of a line. Equation of a line which passes through, if this is the line, find the equation of this line which passes through -1, -1, -4 and is perpendicular. This line is perpendicular to this line, y plus 2x minus 4 equals to 0. So without sweating, if these two lines are perpendicular, what do we know about their gradients? The product of their gradients equals to -1. Therefore, gradient of line 1 times gradient of line 2, m represents gradient. m1 times m2 equals to -1. Therefore, write this equation in the form of y equals to mx plus c. So make y the subject of the formula. Y equals to, when 2 crosses the other side becomes minus 2x. When 4 crosses the other side becomes plus 4. So y equals to mx plus c. So y equals to minus 2x plus 4. So what is the gradient? This is the gradient. So here you just come and collect it. This is the gradient. Therefore, gradient of line m1 equals to minus 2. Then come back here. m1 gradient, which is minus 2, times m2 equals to minus 1. So get get m2, gradient of line m2 equals to minus 1 over minus 2, which is a half. So if this line has a gradient of minus 2, which is here, then this line has a gradient of minus 2. This line has a gradient m2 equals to a half. But you are given gradient. Now we've gotten gradient and you are given a point. So what is the equation of this line? Equation of a line is given by change in y over change in x. Sorry. So what is the change in y? Becomes y minus 4. Y minus minus 4 over x minus minus 1. You get the gradient. Change in y over change in x is the gradient, but our gradient is a half. So when you open up, this becomes y plus 4 over x plus 1 equals to a half. But because our equation was given in this form, we will leave our answer in this form because they've not specified. So you can leave it in the form of y is equal to mx plus c, or in the form of y plus 2x minus 4. Y plus mx plus a constant c. So cross multiply both sides by x plus 1. So y plus 4 equals to a half into x plus 1. Then y plus 4 equals to, when you open up, becomes a half x plus a half. So from here, y equals to a half x plus a half. Then when 4 crosses the other side becomes minus 4. So y equals to a half x minus, when you subtract this, the LCM is 2. Then 2 into 2, 1. 1 times 1 is 1. Minus 2 into 2, 2 times 4, sorry, is 8. So y equals to a half x minus 7 over 2. Is it? Yeah. This is plus, so it becomes minus 7 over 2. So this is the equation of the second line. So you be very careful with these signs. Yeah, this is minus 7 over 2. That is correct. And if you want to leave it in this form, then you just come here and say you open it up. You collect y, y's, they all come on this side, this is y, then equals to a half x, crosses the other side, becomes minus a half x, then this crosses the other side, becomes plus 7 over 2 equals to 0. These and these are all both correct. So, question number 9. A line L1 passes through the points. Line L1 passes through these 2 points, point 33, and passes through the point 57. Then you are told, find the equation of line L1 in the form of y equals to mx plus c. So, when you want to find the equation of a line, when given 2 points, first of all find the gradient of a line. So, gradient equals to change in y, this means change, this sign means change, over change in x, which means that change in y is 7, this is x value, y value, x value, y value. So, 7 minus 3 divided by 5 minus 3 becomes 4 over 2, which is 2. If this is the gradient, the equation of a line, you can use either points. You will get equation of a line y minus 3 over x minus 3. I have decided to use this first point equals to 2. Therefore, y minus 3 equals to 2 into x minus 3. You open up this. So, y minus 3 equals to 2x minus 6, because we want to find it in the form of y equals to mx plus c. So, y equals to 2x minus 6, when minus 3 crosses the other side, becomes plus 3. So, y equals to 2x minus 6 plus 3 becomes minus 3. So, this is in the form of y equals to mx plus c. Next, part B of it says that another line L2, this is line L1. So, part B, if this line is L1, so part B says another line L2 is perpendicular to L1. So, perpendicular, you drop it like that, forms right angle there. So, this is another line L2. This is L1. And passes through the point, minus 2, 3. Find equation of L2. Again, find equation of L2. But I told you, when there are perpendicular lines, then the product of gradient 1 times gradient 2 equals to negative 1. So, what is our gradient here? Y equals to mx plus c. So, our gradient is 2. It is here, m, 2. So, 2 times m2 equals to minus 1. So, m2 equals to minus a half. So, gradient, you divide both sides by 2 by 2. So, m2 is equal to minus a half. Therefore, use this gradient and this point to form an equation of line L2. So, line L2 is change in y. To get this gradient, change in y, which is y minus 3, over change in x, x minus minus 2 equals to minus a half. So, y minus 3 over x minus minus becomes plus 2 equals to minus a half. So, y minus 3 equals to minus a half into x plus 2. Therefore, y minus 3 equals to, when you open the brackets, becomes minus a half x minus 1. Minus a half times 2 is minus 1. Then y crosses the other side, 3 crosses the other side, sorry. So, y equals to minus a half x, then minus 1 plus 3 becomes plus 2. Our answer is that. 3, yeah, our answer is that. Then, the next part of this question says, this is question B part 1. Then question B part 2 says, find the x-intercept of L2. So, L2 from here, the equation of L2 is y equals to minus a half x plus 2. This is the equation of line L2. So part B part 2 says this is one question with different parts. It has part A, part B, B part 1, B part 2. So the question says find the x-intercept of L2 at x-intercept y equals to 0. At x-intercept, note this, at x-intercept y equals to 0. Then just come and replace here. Put 0 equals to minus a half x plus 2. So when a half comes this side, minus a half comes this side, becomes a half x plus, becomes positive. A half x equals to 2. Therefore, x equals to 4. So easy. So easy. So this question says find the x-intercept of L2. X-intercept of L2 is 4 when y equals to 0. The next question 10, solve the simultaneous equation. Don't be tired, please. Let's just hang on. We are almost through. Solve the simultaneous equation 2x minus y equals to 3. Then x squared minus xy equals to minus 4. So simultaneous equation you can either solve by elimination or solve by substitution. So let's substitute. This is equation 1, equation 2. So let's make y the subject of the formula here. So when y crosses this side, becomes y equals to x 2x, then 3 crosses the other side, becomes minus 3. So in the second equation, just substitute the value of y. So x squared minus x into y is given by 2x minus 3 equals to minus 4. So open the brackets to get the value of x. X squared minus 2x squared plus 3x equals to minus 4. X squared minus 2x squared is minus x squared plus 3x equals to minus 4. Then let them cross all the other side so that we make minus x a positive value. Becomes x squared when it crosses the other side. When plus 3x crosses, becomes minus 3x, but 4 remains minus 4 equals to 0. Then this is a quadratic equation. Find two numbers. If you multiply them, gives you negative 4. If you add them, gives you minus 3. So the two numbers, the factors of 4 are 4 and 1. Therefore you say x squared plus x minus 4x, minus 4x minus 4 equals to 0. Solve this quadratically. X, factor x out, x into x squared, x into 1, ones, minus, what is common factor between 4x and 4 is 4. 4x, 4 into 4x, x times, minus is plus, then 4 into minus 4 is plus 1. So you can see these are common, therefore you collect these two, x minus 4 into x plus 1 equals to 0. Therefore, x minus 4 equals to 0, x equals to 4. Then x plus 1 equals to 0, x equals to minus 1. So when x is 4, what is the value of y? Come here, replace. So when x equals to 4, y will be equal to 2 times x, which is 4 minus 3. So y will be equal to 8 minus 3. Y is equal to 5. So when x is 4, y is 5. When x equals to minus 1 here, y will be equal to 2 into minus 1 minus 3. So y equals to 2 times minus 1 is minus 2 minus 3. So y equals to minus 2 minus 3 is minus 5. So these are the values of x and y. So when x is 4, y is 5, and when x is minus 1, y is minus 5. Very easy. Question number 11. Question 11. This is differentiation calculus. X into x squared minus 1 over x minus 1. Find dy dx. This question was in one of the KCSE papers. Just the way it is, and it is 3 marks. So what do? Expand this. When you expand this, you say x into x squared minus 1 squared, something common here, over x minus 1. Here, this is a difference. Use a difference of 2 squares to expand this. This becomes x into x minus 1 into x plus 1 over x minus 1. So, x minus 1 cancels x minus 1. You remain with x into x plus 1. Then expand it, open it up, open the bracket, x times x is x squared, plus x times 1 is x. So what you have here, you find dy dx. You are told differentiate. When you differentiate x squared, you bring 2 down, 2 into x, then 2 minus 1. Subtract the power 1. Plus, here is x raised to power 1, you bring 1 down, x into 1 minus 1. So 2x raised to power 1 plus 1 times x is x raised to power 0. Any number raised to power 0 is equal to 1. Therefore, this becomes 2x plus 1. This is what we get. This is the dy dx equals to 2x plus 1, or this value differentiated comes to this. Question number 12. Binomial expansion will not miss, will never miss. This differentiation will never miss. All these topics will never miss. So you are told expand 1 plus 3x raised to power 5. Expand 1 plus 3x raised to power 5 in ascending powers of x up to the term x cubed, and simplify. So when you are told to expand this, you get factors of 5. By use of Pascal's triangle, you start by 1, 1, 1. We want to get factors of 5. Then 1, 1 plus 1, 2, 1. Then 1, 1 plus 2, 3, 2 plus 1, 3, then 1. Then start 1, 1 plus 3, 4, 3 plus 3, 6, 3 plus 1, 4, then 1. Then 1, 1 this side, 1 this side, it maintains. Then 1 plus 4, 5. 4 plus 6, 10. 6 plus 4, 10. 4 plus 1, 5, then 1. So we have factors of 5 here. We have factors of 5. 1, 2, 3, 4, 5. So this is what we are interested in. So the factors of 5 are these ones. So list them down. When you list them down, you write here, give them spacing, 1, 5, 10, these ones, 10, 1. Then come back here, up here, 1 plus 3x. So the first value 1, just write it everywhere, 1. One, or there's 10, then 5, then 1. Okay, good. So you have to be very careful because there can be an oversight. So 1, 5, 10, 10, 5, 1. So write the first values as all ones, Then the next values as 3x, just below it. Then if the first number will always decrease from the power to 0. From the power given, you can be given 5, 4, 3, 2. So the first value decreases from that power. Power 5, power 4, power 3, power 2, power 1, power 0. The next value, which is 3x, increases from 0. So it is 3x raised to power 0, 3x raised to power 1, 3x raised to power 2, 3x raised to power 3, 3x raised to power 4, 3x raised to power 5. Then expand this. So any 1 raised to power any number, 1 raised to power million is 1, 1 raised to power 1 is 1, 1 raised to power 0 is 1. So this remains as 1. But 3x raised to power 0 is 1. 3x raised to power 1 is 3x. I'm expanding this now. 3x squared means 3x times 3x, which is 9x squared. 3x cubed means 3x times 3x times 3x, which is 27x cubed. 3x raised to power 4 means 3x times 3x times 3x times 3x, which is 81x raised to power 4. Then 3x raised to power 5 is 81 times 3 is 243 x raised to power 5. So what does the question want? The question tells you to expand up to the term x cubed. So just come down here. Where is x cubed? Up to this term. Expand up to this. So you finish, you get these values. So by getting these values, we are going to multiply this as we add them. So 1 times 1, 1 times 1 times 1 is 1. Plus 5 times 1 is 5. 5 times 3 is 15x. 10 times 1 is 10. 10 times 9x squared, remember this one expanded, is plus 90x squared. Then 10 times 1 is 10. 10 times 27x cubed is plus 270, sorry, x cubed. This is our answer. This is what the examiner is interested in, because we've been directed here up to this term, x cubed. If they wanted x raised to power 4, you could have multiplied this, you add. Multiply this, you add. Then that is part 1 of this question. Part 2 of this question. Part 2 of, they are always related. So part 2 of this question, the answer is 1 plus 15x plus 9 squared plus 270x cubed. So this is a very interesting part. Part 2, part B, 12B, says, hence estimate the value of 0.97 raised to power 5. Correct to 4 decimal places. Remember, you are told hence estimate this value, correct to 4 decimal places. So this, we were given 1 plus 3x raised to power 5. So this and this, you equate them. So 1 plus 3x equals to 0.97. These powers, you just assume them. Therefore, 3x equals to, collect the like terms, 0.97 minus 1. So 3x equals to minus 0.03. Get the value of x. Divide both sides by 3, divide by 3. So x equals to minus 0.01. They want you to expand. So where there is x, you replace 0.01. So come back here, up here, 1 plus 15x. 15, but x is minus 0.01. Okay? Plus 90x squared minus 0.01 squared plus 270 x, which is minus 0.01 cubed. So when you expand this, becomes 1 plus, when you expand this becomes 1, then we have 1 plus 15 times minus becomes minus, but it is 15 times minus 0.01, so only to 2 decimal places is 0.15. Then minus 0.01 squared becomes minus 0.01 times minus 0.01. Minus and minus becomes plus. Then 0.01 times 0.01. 1, 2, 3, 4. 4 decimal places. So when you multiply by 90 becomes 0.0090. Then minus 0.01 cubed becomes minus 0.01 times minus 0.01 times minus 0.01. So minus times minus times minus. Minus times minus is plus. Plus times minus is minus. Becomes to 6 decimal places. 1, 2, 3, 4, 5, 6. So becomes 270 times 0.01 cubed. So becomes minus 0.123456. Then expand this. 1.00 minus 0.15. When you subtract these two, becomes 0.85. Then add this. Add 0.00900090. When you add this, 0.9580. Then you subtract this minus 0.1230000270. Borrow 1 from 9 becomes 8. 10, 9, 10, 3. 7 minus 9 minus 2 is 7. This comes to 8, 5, 8, 0. You can use your calculator. So this comes to 0.85873. But they want correct to 4 decimal places. 4 decimal, 1, 2, 3, 4. You look at the fifth one. If it is less than 5, then it takes its place value is 0. If it is more than 5, then it adds 1 to the 4th decimal place. So because it is less than, it's 0. So the answer is 0.8587. Oy. Very easy. Next. Question 13, we are almost through. Question 13, solve for y in 5 into 2y plus 1 equals to 4 into 5 y plus 1 minus 15. So you are told to solve for y in this equation. Solve for y. So this is easy. Open up this. When you open up, this becomes 5 into 2y times 5 raised to power 1. These are by laws of indices. By laws of indices. This 5 into 2y plus 1 means 5 into 2y times 5 raised to power 1 equals to 4 into 5 raised to power y times 5 1 minus 15. Then from here, let 5 raised to power y, because we have 5 raised to power y here and 5 raised to power 2y. So you can let 5 raised to power y be equal to p. Therefore here becomes p squared. 5 raised to power y, then 2 becomes p squared times this 5 equals to 4 into 5p times 5p minus 15. So 5p squared equals to 20p minus 15. Divide everything by 5, by 5, by 5. So p squared equals to, by 5, sorry, not 2, equals to 4p minus 3. Bring them on this side. So p squared minus 4p minus 4p crosses the other side becomes minus 4p. Minus 3 crosses the other side becomes plus 3 equals to 0. Then this is a quadratic equation. Look for two numbers. If you multiply them, gives you 3. If you subtract them, gives you minus 4. So the two numbers are factors of 3, which is 3 and 1, becomes p squared minus p minus 3p plus 3 equals to 0. Then factor p out, p into p minus 1 minus, common factor here is 3 into p minus 1. So because these and these are the same, so take p minus 3 into p minus 1. Therefore, this one equals to 0. So p minus 3 equals to 0, p equals to 3. Then p minus 1 equals to 0, p equals to 1. From here, class, we are not done yet, so be attentive. So when p is 1, what is the value of y? Because we are interested in the value of y. So come and replace p. We will have two values of y. So when p is 1, let's start with that. So 5y equals to p, which is 1. Any number raised to power 0 is 1. So if this is 5, we can decide to make this to base of 5. But how do we make it? So 5y equals to, if this is 1 means, 5 raised to power y, 5 raised to power y equals to 1. Therefore, 5 raised to power y equals to, you make this to base 5, becomes 5 raised to power 0. Then by laws of indices, if the bases are the same, you equate you equate this, which is y equals to 0. So when the bases are the same, you equate their powers. So y equals to 0. So the first value of y is 0. What is the next value of y? Because p is 3. We had two values of p. So 5 raised to power y equals to 3. So in such a situation, you introduce logarithms. Therefore, you say, when you want to open up this using logarithms, you say y log 5. Y log 5 equals to log 3. Then logarithms, they are assumed to be, they are to base 10. So you don't no need of writing base 10. Then y equals to log 3 divided by log 5. When I used to be in high school, log 3 used to be 0.4771. And I think it has still remained the same. CBC might have not changed it. Then log of 5 is 0.6990. Now you use your calculator. Me, I have a working calculator here in the mind. So y equals to, when you divide 0.4771 using a calculator, divide by 0.6990, you get 0.68. 0.68 something. So divide this, you get your answer as the value of y. I think that is very proper. 0.683, I think so. So these logarithms, do not do them often if you are not sure. If you are not sure like I am sure, then you don't do them often. Just use your calculator. Then question number 14. Solve for x in the equation 32 x minus 3 times 8 x plus 4 equals to 64 divided by 2 raised to power x. So you are told to solve for x. So we can see the bases are different. So make them to the same base, because these are indices. You make them to the same base, then you collect their powers. If they are multiplication, you add their powers to the same base. If they are division, you subtract their powers to the same base. So 32 is the same as 2 raised to power what? 32, 2 here 16, 2 here 8, 2 here 4, 2 here 2, 2 here 1. So it is 2 raised to power 1, 2, 3, 4, 5. So 2 raised to power 5 into x minus 3 times 8 is 2 raised to power 3 into x plus 4 equals to 64. 64 is 2 raised to power 6 divided by 2 raised to power x. So we've made them to the same bases, base 2. Therefore, just where there is multiplication, you just add. The laws of indices says that once you have the same bases, you add the powers. So this becomes 2 raised, so you add the powers but you drop the bases. So this becomes 5 into x minus 3 plus 3 into x plus 4 equals to, when it is division, you do the opposite. You subtract the powers, 6 minus x. Open the brackets. 5 times x is 5x minus 15 plus 3x plus 12 equals to 6 minus x. Collect the like terms. 5x plus 3x. Then x crosses the other side, becomes plus x, equals to minus 15 crosses the other side, becomes plus 15, plus 12 crosses the other side, becomes minus 12. Then we have 6. So 5x plus 3x is 8x plus x is 9x equals to 15 minus, by BODMAS, 15 plus 6 is 21. 21 minus 12 is 9. So x is 9 over 9, which is 1. So x is 1. How sweet. Only 5 more questions, 6 more questions. So we are going to question 15. So kindly hold on. In the next few minutes we'll be done. Question number 15. This is matrices. Find A. The matrix A equals to 2k 3k plus 2 has no inverse. This matrix has no inverse. Find k. 2 marks. Find k. So if a matrix has no inverse, it means it is a singular matrix. It is a singular matrix. In a singular matrix, the determinant equals to 0. In a singular matrix, the determinant equals to 0. But how do we get the determinant? The determinant is the leading diagonal times the preceding diagonal. Sorry, the product of the leading diagonal minus the preceding diagonal. So the leading diagonal is 2 times k plus 2, this, minus k times 3 equals to 0. Therefore, open the bracket, 2k plus 4 minus 3k equals to 0. So 2k minus 3k is minus k equals to 4 crosses the other side, becomes minus 4. So k equals to 4. Very easy. Question number 16. Question number 16. A transformation, this is a topic on transformation, but is also on matrix. I didn't put it there. So it's another extra one. So there are a total of 13 topics. A transformation whose matrix is a combination of 2 topics, whose matrix is 2x minus 1 minus 3, 2x. A transformation whose matrix is this maps a triangle with an area maps a triangle with an area 4 centimeters squared onto another triangle with an area of 36 centimeter squared. Calculate the value of x. So this is simple. We have a transformation matrix to transform this area object into this image. This matrix transforms the object into an image. Therefore, the determinant of this matrix, determinant of the transformation matrix, times area of object equals to area of image. So the determinant of this matrix times this area of the object equals to the area of the image. So the determinant here is x, the leading diagonal, into 2x minus 1 minus 2 into minus 3. This is the determinant. This determinant times the area of the object, which is 4 centimeters squared, equals to the area of the image, which is 36 centimeters squared. So open this bracket. X times 2x is 2x squared minus x times minus 1. X times minus 1 is x. Then minus 2 times minus 3 is plus 6 into 4 equals to 36. So this you can divide both sides by 4 to simplify it. So we have 2x squared minus x plus 6 equals to 9. 36 divided by 4 is 9. Therefore, bring 9 the other side. 2x squared minus x, 6 minus 9. So 2x squared minus x minus 3. 6 minus 9 is minus 3 equals to 0. Again, quadratic equation. Solve the quadratic equation. Get two numbers. If you multiply them, gives you minus 6. If you add them, gives you minus 1. So the factors of 6 are 2 and 3. So here we get 2x squared plus 2x minus 3x minus 3 equals to 0. Collect 2x squared and plus 2x. The common factor is 2x into x plus 1 minus common factor here is 3 into x plus 1 equals to 0. So 2x minus 3 into x plus 1 equals to 0. Therefore, 2x minus 3 equals to 0. X equals to 3 over 2. This side, x plus 1 equals to 0. X equals to minus 1. So we have two values of x, which is 3 over 2 and minus 1. Okay? Question number 17. 4 more questions. Question number 17. Simplify without using tables. Without using tables, simplify log to base 10 of 2 plus log to base 10 of 8 divided by log to base 10 of 24 plus log to base 10 of 9. So by the laws of logarithms, we want to solve the numerator first, then we come to denominator. So the numerator, by laws of logarithms, if the bases are the same, then the laws of logarithm says that you just multiply. If you are adding logarithms, you can multiply these two values and then you put them to one base of 10. So log to base 10 of 2 times 8 divide by log to base 10 of 24 times 9. This becomes log 2 base 10 of 16 divided by log 2 base 10 of 24 times 9, 36 carry 3, 18, 216 of 216. Then further simplify this. Remember, you're told don't use tables. So 2, get factors of 2. We want to make this to be the same, and we see if we can solve it. So 16, factors of 16, 2 here, 8, 2 here, 2, 4, 2 here, 2, 2 here, 1. So this is the same as log 2 base 10, log 16, log 2 base 10 of 16 is the same as log of 2 raised to power 1, 2, 3, 4 to base 10. I've just rewritten this 16 in this form. Simplifying it. Divide by 16, we want to simplify 216. 2 here 108, 2 here 54, 2 here 27, 3 here 9, 3 here 3, 3 here 1. So this is 2 raised to power 3 times 3 raised to power 3. So divide by log 2 base 10 of 2 raised to power 3 times 3 raised to power 3. So in this form, this gives you log 2 base 10 of, just multiply 2 times 3 is 6, then take their base, take their powers of 3. Are we together, class? 216 can be written as 6 raised to power 3, which is 6 times 6 is 36. 6 times 6 times 6 is 36 times 6, which is 216, which is 6 raised to power 3. So 6 raised to power 3. So this comes to log 2 base 10 of 2 raised to power 4 divided by log 2 base 10 of 6 raised to power 3. Then by laws of log, you can bring 4 the other side of simplifying further becomes 4 log 2 to base 10 or log 10 to base 2 divided by 3 log 6 to base 10. So this is simplified. That is our answer. So the answer is 4 over 3 of log to base 10 of 2 divided by log to base 10 of 6. Sawa sawa. Question 18. Tunamalizia. Question 18. Without using tables or a calculator, find the value of log 128 minus log 18 divided by log 16 minus log 6. So if you are not given the bases, then it is log to base 10. So the other one was addition, this one is subtraction. So if it is addition, you multiply. If it is subtraction, you divide. Therefore, you just divide, you collect log 128 minus changes into divide by 18. Then log of 16 minus changes to divide by 6. So when you open this, is log, then 128 divided by 18. 2 here 9, 2 here 64 becomes log of 64, log to base 10 of 64 over 9 divided by log of 16 divided by 6, 2 here 3, 2 here 8, 8 over 3. So from here, look at the numerator, everybody. Class, look at the numerator. Here we have log 64 is 8 squared. Divided by 9 is 3 squared. This can also be written as log of 8 over 3 squared. 64 is 8 squared, 9 is 3 squared, which is log of, when you combine them, is just 8 over 3, everything squared. I've just simplified this further. So you come here, you say log of this numerator 8 over 3 squared divide by log of 8 over 3. Then by the laws of log, you drop the power this side. This comes to 2 log 8 over 3 divided by log 8 over 3. So whenever you divide logarithms, in principle, do not show by cancelling. You just drop them. If you cancel, you are wrong. Although this cancels this, but do not cancel, do not show on your working. So in principle, you just drop. You say drop them. Therefore, your answer becomes 2. You drop. If you cancel, you are wrong. Question 19. I know by now you must be in love with me as your teacher. Question 19. This is what we call dispensing knowledge carelessly. Question number 19. If only 2 more questions, so just hold on please. If this is fractions, very easy. If 2 over 3 is added to the numerator of a certain fraction, the fraction will be increased by 1 over 21. And if a half is taken from its denominator, the fraction becomes 2 over 9. Find the reciprocal of the fraction. 4 marks. So let the fraction be equal to a over b. So you are told this is the numerator. Just follow the instructions, then this is the denominator. So you are told if 2 over 3 is added to the numerator, get your fraction a, add the numerator 2 over 3. The denominator still remains. If 2 over 3 is added to the numerator of a certain fraction, the fraction will be increased by 1 over 21. So the fraction which is a over b is increased by 1 over 21. And if a half is taken from its denominator, this is equation 1, and if a half is taken from its denominator, so the fraction is a over b, if a half is taken from here, that fraction becomes 2 over 9. Find the reciprocal of the fraction. So first of all, let us find the fraction. So by finding the fraction, we simply simplify this. This is 4 marks. So just simplify, but be very keen. Be very keen as you simplify. So I want to deal with this alone. I want to deal with this. So when I deal with this, I want to deal with the numerator. So a plus 2 over 3 over 1, get the LCM, 3. 1 goes into 3, 3 times. 3 times a, 3a. Plus 3 into 3 once. 1 times 2 is 2. So we have this as this. I've just simplified this. Then divide by b. Over b means this 3a plus 2 over 3 divided by b over 1. When you open this up, becomes 3a plus 2 over 3 times 1 over b. So this comes to 3a plus 2 over 3b. This. Then equals to, you can bring this ab on this side. When you bring ab on this side, becomes minus. So from here, 3a plus 2 over 3b minus a goes the other side, becomes minus a over b equals to 1 over 21. Then solve this side. LCM is 3b. 3b into 3b, 1. 1 times this becomes 3a plus 2. b into 3b becomes minus 3 into a equals to 1 over 21. Okay? So 3a from here, class. Let me come up here. So 3a minus 3a is 0. 3 from here. 3a minus 3a is 0. Therefore, you remain with only 2 over 3b. So 2 over 3b equals to 1 over 21. Then 2 over 3b multiply by the reciprocal by 3b equals to 1 over 21 times 3b. 3b and 3b. So 2 equals to 1 over 21 times 3b. Then 3 goes here once, 3 goes here 7 times. So 2 equals to b over 7. Multiply both sides by 7 by 7. So 14 equals to b. So our b is 14. What about our a? If b is 14, what is a? Replace it here. Replace it here. So a over b minus a half. A over b is 14 minus a half equals to 2 over 9. So 14 minus a half is 13 and a half. 13 and a half. So a equals to a over 13 and a half equals to 2 over 9. Then a from here, come here, a equals to 2 over 9. Multiply both sides by 13 and a half, this side by 13 and a half, times 13 and a half. So a equals to 2 over 9, but 13 and a half is 27 over 2. 2 and 2. 9 here once, 9 here 3. So a equals to 3. So what is our fraction? Is a over b, which is 3 over 14. But the question wants the reciprocal of this fraction. Reciprocal means b over a, which is 14 over 3. Very easy. Very easy. You just have to be keen. Then the last question, number 20. Then there's something I need to tell you very important. Question number 20. 0.016 without using mathematical tables or calculators, evaluate 0.0168 times 2.46 times 7 divide by 5.74 times 0.112 without using a calculator or mathematical tables. So what do? Solve the numerator first and then come to the denominator. So the numerator, we want to get rid of the decimals to change this number into whole numbers. So this will be 168 times 246 times 7 divide by how many decimal places? 1, 2, 3, 4, 5, 6. So divide by 1, 2, 3, 4, 5, 6. I've just read it. This number rewritten comes to this. Then this means divide by this number numerator, which is 574 times 112. Also divide by 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. Therefore expand it further. 168 times 246 times 7 divide by 1,000,000. Divide by, if you want to get rid of divide by, you replace by multiplication. Divide by 100,000, this over this, over 574 times 112. Now this one you just simplify. When you simplify, you just cross 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. So remain with 10 here. Then 2. Let's use 2. 2 goes here, 56. 2 goes here, 123. 1, 2, 3. Then 2 goes here, 28. 2 goes here, 84. 84. Then 2 goes here, 14. 2 goes here, 42. Then 7 goes here once. 7 into 57, 8 times, which is 56, remainder 1, into 14, twice. Then 2 goes into 42, 21 times. 2 goes into 82, 41 times. Then 7 goes here twice. 7 goes into 21, 3 times. Then 41 goes here once. 41 goes here 3 times. 41 once, 41 into 123, 3 times. So we remain with 3 times 3. Have we finished? Yes. 3 times 3 over, down here we have 10, and this side we have 2 times 2, which is 9 over 20. Class, this is the end of our class, and I want to thank you very, very much for concentrating, and I want to assure you that should you proceed with practicing, then it shall make perfect. The few weeks remaining will be sufficient for you to prepare for your exams, and I know you shall pass. Have a good night until we meet next time. Do not panic. This exam is not a test for your whole life. This exam is just a subset within a set in itself. It's just a very small thing in your life. And I believe that when you revise properly, you will pass. You started from Form 1 to Form 4. There is no option. You can't fail. You will pass. Because if I can remember these things way from, I was in Form 1 in 2002. I finished Form 4 in 2005. So, from 2002 to now, 20 years later, then these things are so easy you can still pass. Thank you and God bless you.